Will you do an introduction first, or I'll just
Yeah,
straight start? Okay.
I'm doing indeed the introduction.
Okay.
So, hello, hi everyone. Welcome to this 41st Urbania conversation, for which I have the great pleasure of welcoming Roy Lin. Hi, Roy.
Hello, hello, Hubbard, and all the folks.
So, great pleasure of welcoming you to this actually very hot and also expected topic like agentic AI and urban planning. And indeed, this is really a topic that we've been discussing a lot extensively the last few weeks, the last few months. If you've been following other Urban AI conversations, our work with the Urban AI Academy, and it's also created a lot of discussions, actually a lot of questions. So it's really a great pleasure and quite timely, actually, to welcome you, Roy, to explore this topic with you. Just a few words very quickly about Urban AI. Urban AI is a global organization dedicated to the emerging field of urban artificial intelligence. We federate a think tank with which we are doing research experiment in the field of urban AI, a community also of international experts working at the intersection of AI and cities, and lastly, an academy through which we are regularly doing like module learning modules. The last one actually was also on LLM. And as part of our mission, we are regularly organizing urban AI conversation to create debate, discussions online with global experts, practitioners, researchers in the field of urban AI. And today, for this 41st Urban AI conversation, we have the great pleasure of welcoming Roy Lin, who is urban informatics team lead at City Science Lab at Taipei Tech. We will first have a 20-minute presentation by Roy on actually how agentic AI can be used and integrated into urban planning and mobility simulation. I'm not spoiling anything. You will see it's really fascinating. And then we will have a fireside chat, as usual, 40 minutes fireside chat to explore and going a bit deeper in those topics. As usual, if you have any questions, any remarks, any observations, please feel free to use the chat. And you know, if you've been following previous episodes, that I will definitely be sharing, asking your question with our speaker today. And you can also use the chat just to introduce yourself and present like who you are, what you are doing, where you're from to other participants. Roy, the floor is now all yours for your presentation.
Okay. Okay. Thank you so much, Hubbard, for inviting me. And actually, I've been following Urban AI for quite some time. I've been always a fan and admire the work and also the exciting sharing online, especially these days. We do need this kind of knowledge sharing across the world. So I think it's not just timely, but also encouraging, even for myself. And happy to chat, especially for the later session. Um, okay, so today's the topic itself is quite wide, but I'll elaborate a bit more on agentic AI. I'll very briefly introduce myself. I was trained as an architect and urban designer. I studied at Harvard GSD for my master's degree. I was originally practiced for like rather traditional urban design at ACOM, which is a well-known global corporate. But later on, I find myself more into urban research rather than just doing design. I still love design, but I think designers or planners really need to understand cities better with better tools, ideally more scientific. So I quit and I started a nonprofit urban research community based in Taiwan called IVC Invisible Cities. At the time, we were using a lot of open data released by the government to do urban analytics and visualization. We do a lot of mapping and we do a lot of event sharing, so try to advocate this new way of looking at cities. And I did my own startup back in Shanghai called Civic Intelligence, literally using more or less the same approach, using data to look at city, to understand city, but for private sectors or for retailers or real estates. At the time, we called it location intelligence. And later on, I joined Taipei City government to help them to set up the very first urban data big data center. We name it as Urban Intelligence Center because we want to help the government make smarter policy based on evidence-based approaches. And recently, last year, I joined City Science Lab Taipei. I'll introduce that later. I also teach at the university, so that's briefly about myself. Yeah, this is City Science Lab at Taipei, and now you see the gentleman with gray hair is Ken Larson. He's the founder of City Science Lab MIT, and this is the video that took place at Taipei Lab. So you can see roughly the environment that we discuss, and we really emphasize on hands-on working, doing prototypes, or trying to make science from theory to practice, try to bridge the gap. And nowadays we have about 10 sister labs around the world. Every year we will gather together to do this City Science Summit. I just flew back from Chile from the summit at BOBO City. So this is one of the value of the network, that we share knowledge and we exchange what we've done, and hopefully to solve different cities' problem or exchange the solutions. Yeah, so back to today's topic, agentic AI or AI in general. I'm going to share two projects that we do at the lab. The first one is called Urban Mobility Simulator. It's an ongoing project. We've been working on it for quite some time, but it's as we continuously refine it and change it or implement it with different stakeholders. This is if you ever had a chance to visit Taipei, I'm more than happy to tour you. This is the installation of it we have at the lab. But let me explain you how it works. Before I get into the detail, I want to give you a heads up about what is typically done in the past, how people used to simulate traffic. Usually they use a method called agent-based modeling. And it's a rule-based sort of simulator. Rule-based meaning, say I want to simulate car behavior, and a car would prefer going straight if there's no traffic jam in the front. If there are traffic in the front, then the car should turn right, right? If the right is also jammed, you will turn left. The least you want to do is do a U-turn. So this is a very basic rule, for example. And imagine you can deploy all different origins and destination, applying all these rules, and you can deploy 1,000 cars in a simulated environment and see how they behave. This is a traditional way of we call rule-based simulation. It has its merits. It's simple, it's understandable, but the disadvantage of that is also quite obvious. It's a very simplified behavior. Nowadays, we have generative AI, specifically using the LLM, we are able to do much more complicated behaviors based on the generative AI's inputs or the sort of the knowledge or the common sense that the model itself has already to offer. So we can do much more granular, much more realistic behavior simulation, but of course, at the same time, it's computation intensive. Yeah, this is roughly how the workflow look like. We start from here. The agent means in each simulated citizen or each individual. We start from using LLM. We feed the model with the census data, meaning how many people of what gender are living in the city of Taipei, or what's the income level of different groups, gender proportions, or education occupation, everything that we can get from the public data. We use that, and also with some other data source like Google EIE, which is a global covered estimation of the proportion of people using different transportation mode. We use that as a background knowledge to sort of confine or to regulate LLM's output. So we will have imagine LLM writing backstory of each simulated citizen, different age, like 60 years old, PhD in finance, income level, this type of amount of US dollar per year, this type of thing. And we use an iterative process to make sure that the sum of the simulated individuals, the overall population, matches the target city. And then once we have each individual story profile being made, then we do this scheduling, we do the itinerary of the whole day. From there, we do origin and destination pairing. We dump everything from the real city. We literally create more or less a digital twin of the real city, the actual roads, the actual point of interest in the city, the actual land use, the actual transportation system. And for the fake citizen, and to allocate them in the city, and we do the routing based on their itinerary, and we see how the 24-hour of the simulated city would look like. And I'll walk you through a more visual representation so that you can understand this easier. So imagine this is one of the agent. It's a 45-year-old PhD data scientist, prefer car and walking. And we use CVP data, the telcos for traffic data, to allocate their residential area or working area. Then each of the agent would have a origin, their homes. So and there will be a generated schedule of the agent. So on the screen you can see in the very early morning, this agent will get out of bed and having some breakfast and go to the office, which is what we call the frequent destination. He will go there to walk, take a car, drive a car to the office and to check the email. And there's also, like, during the day, occasionally you would visit some restaurants or cafes based on this character and his full day schedule. So if, for example, he will take a break and eat a lunch with a colleague at noon, and we will pair the trip to the nearby restaurant, which also matches his preference. Yeah. So imagine that the LLM is writing literally the backstory of this character and the whole day itinerary of the character. And the system that we build will pair each activity to the actual location. And then we do the routing algorithm and deploy like 10,000 agents in the city. So you can literally see where they go at different time of the day and what they're doing at the moment. But this is not, I mean, it looks interesting. This is literally like a game, kind of same city kind of environment. But this alone doesn't tell you much, right? So the system becomes more powerful when we aggregate the trips all together. Now you can see this is what we call the heat map of every trip. So for 10,000 simulated citizens in a city throughout the day, where do they actually go? As you can see, let me pause here a little bit. So for example, here, we can isolate how many people are walking in different area during the morning time. And if you're familiar with the city, you understand that these tracks are literally originated from the MRT stations to their workplace, or the other way around, right? So you can use this system to actually understand, okay, this amount of citizens in a city throughout the day, which pathways are actually more important than the other ones. And this system can actually be even more powerful, say, if the government want to change the certain routes of a bus, how would that impact the overall transportation? Or because, like I mentioned, all the urban fabric, the city contacts are coming from the real. It's almost a digital twin of the real city. So we can also simulate if I want to change a certain area from residential to mixed use or to commercial, or we want to increase the FAR of a region, how would that impact overall transportation, or how would that impact the carbon emission? So this is a sandbox tailored for different future scenario simulation that we can easily plug and play, and there's much more dynamic than the traditional agent-based model. Yeah, so this is the first project that I want to share. Let me share you also the second project. This is called City AI. City AI is another project that we use agentic AI technology and equipped with urban data so that the AI can automate a lot of urban analytic work for human. In order to do that, first of all, we need to process the urban data. Typically, if this is a city, there are all kinds of data format describing the city. There are vector data. Vector include points, lines, polygons. If you're working with GIS, you know this very well. There's also raster, like satellite images or contour or whatever raster. So it's really complicated when you deal with spatial data processing, right? Preparing data itself can take the majority of work. So the first thing that we do is we sample everything and we pre-aggregate them onto space grids. And also we pre-aggregate them at different levels, different resolution. For example, if we want to look at, if we want to analyze street level amenities, we want much granular hexagons. But if we want to compare region to region, we might use a larger hexagon or spatial grid to do this comparison. And there are many merits about pre-aggregation into grids. One of them is to make the data AI ready. AI ready means not only the AI agents are easy to use the data, to access the data, but they are easier to use for training prediction models. Then we process all kinds of hundreds of data that's available in Taiwan and pre-aggregate them and process them into something like this. So you will see different size of the grids, and if you zoom into like more building level, you will see the resolution increased. In this hexagon grid system, we can do all the way to interior levels, like 80 centimeters by 80 centimeters size. Yeah. So once we have that, so imagine we have a spatial temporal database built and ready and pre-processed for AI. And we also add a human and AI interface. What's happening in between is that we introduce all kinds of AI agents. And I always find, using technical drawing to explain what agentic AI is, it's really, it's not really user-friendly to all the audience without a technical background. So I find the most effective way to explain this is to imagine all these little minions. They are specialized in different works. So for example, if the human says, okay, tell me something about a city, tell me about the population of a city, and there's a little minion, little AI agent, who is a PM, a project manager, you break down the task and say, okay, here's the plan. This is the first step, the second step. And then there's a data scientist or a data fetcher who's really good at getting the data. Okay, he will say, okay, let me take a look into the data sets, see if we have such data. And there's a data visualizer, really good at visualizing the data, really good at knowing what charts before what purposes. We do the visualization. And I'm going to do like really quick showcase of the thing that we actually built. This is data acquiring and visualization. This is like very entry-level use cases. We can tell the AI or like, for example, show me in the past 5 years, how's the aging condition change over time? right? It would plot you the chart and also the maps, and the user can easily drag different time throughout the years and to see how everything are going on. And also the agent AI would summarize the findings on the left-hand side. So this is a very basic use case. And the more advanced is that you can do geoprocessing on the fly. So for example, if I want to do like site selection, I want to look at cheap housing near subway station, also near open spaces. Usually you would need multiple steps of geoprocessing. You need to get the data, do the buffer area, do intersections of different layers, and then you also need to look at the area and pull the housing data to look at which area is more affordable, right? So in this case, you don't really need to learn GIS at all. You don't even have to be a data analyst yourself. You just need to ask the question, and the AI would do the processing for you, and you just look at how it's processed, and you can insert feedbacks of any time. And here you go. You have a visualization of where the most affordable housing is that matches your criteria. And the last one is when these specialized agents are equipped with pre-trained downstream models, like in this case, what we show is the traffic prediction. So we pre-train a model that's specialized in traffic prediction, and having the AI agents the access to the tool. So once the user is asking about, oh, in the future, when the high-tech park is being built, how would that affect surrounding transportation? Then the AI would based on the parameter change, then would run the simulation and tell you what's the future is going to be look like. So these are the three different use cases of what will build the city AI. I would say usually when people talk about AI or machine learning or deep learning, it comes to different phases, right? They'll always prescribe as an ultimate goal. So you would have like data analysis, you would have like prediction, and you would have prescribe at the ultimate goal. But I mean, we haven't get there yet. We haven't been able to let the agents to prescribe for human. Prescribe requires domain expertise. So imagine we can equip them the knowledge from experts. Yeah, then presumably you can offer good suggestions. We haven't gone there yet, but I've been thinking about the other type of working mechanism is back to this diagram. So instead of we tell them what to do, what if we equip them certain curiosity of the world, saying maybe they're constantly looking at the data, even without human supervision. And for example, one agent would say, okay, I spotted something interesting. Look at here, there's more crime rather than that place. Why? It's so interesting. And the other agent would come in and say, okay, making some hypothesis, maybe because here we have less traffic light or something. And maybe the other data scientists would come in and say, okay, let's do some statistical analysis, see if that's really the case, right? Maybe they will find otherwise. And there's a domain expert in the field saying, okay, it's not about the traffic lights, right? It's about something else. Then they internally debate, come to consensus, and report back to human being, and with some interesting findings. This is what I call it the Y machine. Imagine the AI agents work as a bunch of data science or scientists in general, but with like rapid speed and 24-hour. But they will share back what they learned or observe with human. So they work with us not as tools, but as peer that actually co-work with human being. So back to this diagram, I think there is a chance where we can use the agentic AI in the urban planning setting to better explore and discover the nitty gritty or the complexity of city, because city is so complicated. And that's also what is so fascinating to me. If we can allow the agents to observe by themselves, to make hypotheses, to validate for themselves, and to try to reason the findings, try to summarize the finding and report back. And these become a feedback loop that the agent is not just the tool that work as they're told, but they can be more autonomous. Like, yeah, they can do their own decision. They can even debate or fight with each other, and only come to consensus and share back. Okay, so this is the last page of what I share. I talked about 2 projects. We have submitted papers and they're all published. So if you're interested, you can look up the paper for more detail. And also, if you're keen to stay connected, you can link me on LinkedIn or email me. Yeah, thank you so much.
Thank you. Thanks, Roy, really for the fascinating presentation. That was actually really very clear. So thanks a lot for explaining in such a detailed way how works agentic AI, as well as its potential for planners and urban stakeholders. I really love your comparison, your image with minions. That's
Okay. Yeah.
that's a wonderful one, and it's also avoids anthropomorphism, which is really more than welcome. Um, I might actually have the first question. So you really cover the different multidimensional potential of LLM and agents
Mm.
AI for urban planning tasks and work, and that was really interesting to see that it can be used within urban simulation, but also to
Mm.
assist in some,
Yeah.
let's say, like digital tasks. And I'm wondering, what does it take very concretely for, let's say, some planners, so that do not have very high techniques in, like LLM,
Mm.
to implement some of those agents, either for simulation or to assist them in geo tasks in their own workflow?
Yeah. Well, one of the reasons why we try to build CDAI is literally try to solve that issue, because I myself was trained as urban designer, and I literally well, GIS was taught at school, but not data science, and of course not coding or programming in general. So there's a lot of urban planner or designers who want to adopt these skill sets, but find it really hard because, first of all, they have no time, and also it's quite a steep learning curve. So that's particularly why we want to make CDAI, because it sort of lower the bar of technical barrier for everyone. Like it's similar to ChatGPT lower the bar of all the knowledge in the world. You can literally ask anything. It's great to know the basics. Of course, it doesn't replace experts, but it does provide you the base knowledge of almost everything. Uh, CDAI would help you to do most of the technical stuff. Of course, there's always limitation to that, but this type of tool will, I always say, it's democratizing urban intelligence for all, not just urban planners. But of course, urban planner should be more sensitive or more sort of able to ask the right question, or to judge the process whether or not that they're accurate, right? So, but they don't have to do the tedious work themselves. Like I mentioned, when I do an urban analysis myself and data science myself, I spend like 70% of my time just getting the data, cleaning the data, and maybe 10% of my time processing the data, only 5% or even less than that to actually analyze it, writing the reports, or come up with strategies. So that's really a waste of time. So I think, and the good news is it's not just that the lab is doing such tool. There are plenty of other startups or other academia, or even the big players like Google. They are implementing more or less the same thing, or like Easery or Carto. They're all doing not quite the same, but I think the idea is there. How to use LM or AI to democratize this spatial understanding for most of the people. So I think it's even more critical for urban planners, because nowadays you don't have excuse to say there's no data. You don't have excuse to say you don't know GIS or geoprocessing. You don't know data science. But you need to focus on asking the right question, finding a solution. Yeah, I think that will accelerate the profession in general. Yeah.
Yeah, like generative AI is really lowering barrier to access, as you said, urban data and urban AI capacity and potential. And really, thanks for reminding it, because indeed, as you said, it's potentially an opportunity to democratize this intelligence. In your case, I'm resonating with a question from Santiago Pardo, who is asking, have you any beta version to your own software? And
Hmm.
I might ask a related question, which is, uh, how can I work with your software? Let's say I'm based in Lisbon, or if I'm
Hmm.
based, I don't know, in New York. Is it possible? Can I use your software? Should I upload some data? How does it work?
Well, yes, we are planning to release a test version, a beta version, maybe early next year. Uh, So if you're interested, you can sign up. I can share the form later on, but we do want to gather a first pilot user to give us feedbacks and how they use it, or if they found it useful, or what's the thing that we can improve. We are going to release early next year, hopefully. Um, but we're also figuring out how to make it more open, because right now it's using our local hosted database, and also all the agentic framework is local host. We are thinking how to open it up more open. And like I mentioned in earlier slides, that we are part of the City Science Network. So, for example, the BioBio Lab with Taipei Lab, we are discussing how to use a City AI, or how to share the framework, and so that the team in Chile can actually benefit from what we built. I think we're still planning on that. I think the goal is there, is clear, but we just haven't yet figured out how to do that. Maybe we will release the open source version of the tool, so people can actually reuse it to build their own software, or we can co-host all the data in the background, and and having whoever want to use just access the web page, because the infrastructure that we build, also including the hexagon, the spatial grid system, they are global covered. The only thing that we need to add is the regional data. And luckily, the data source that we pull into our pipeline, uh, many of them are global covered. Like we use OSM, we use Google Map, we use many other global covered data source. Of course, for the sake of Taiwan domestic use cases, we have to pull like data from local government as well. So if, like for example, BioBio in Chile, they want to enrich the data sets, they just you know identify the relevant data sets, and we can share the data database or data protocol together, and then the AI can just move from one city to another, move from one continent to another, just do exactly the same task. So I think that's doable, but we're still working on it to see how can make it more open and scalable. Yeah.
Okay, super interesting. This how you work in a very network way with other city science lab. We welcomed. It was 1 year, almost 1 year ago now. Ariel Neumann, that some
Mm.
members of our audience or participants might know. So he also shared super interesting projects on AI agents, which is available on our YouTube channel. That was really a very much appreciated video. I might have a last question for you, Roy, before we let enter a special guest.
Hmm.
Um, you mentioned this idea in a sense of encoding curiosity, which is really super interesting. And I was wondering, what does it involve? Like, how do you encode curiosity into your AI agents?
Yeah. So I think curiosity is a very vague terminology, but I think it does capture the the intention. Nowadays we can do prompt engineering, right? You could say, okay, you're curious about a certain issue, and you would do whatever it takes to know the answer. This is how we can do nowadays. Although the AI agent doesn't really have a soul, doesn't really have a desire, but it would do as it's instructed. When I say equip them with curiosity, I don't mean necessarily technically we prompt engineer them like that, but somehow make those agents have a ultimate goal of understanding the world. Because right now the AI tool that we use, they don't care anything about what's going on, right? You just tell them what to do and they do it perfectly. If you tell them, okay, you want to know everything, it doesn't really know what where to start, right? It's not instructed. But what if the model at some point it can't understand this vague instruction, or we can literally using the prompt engineering to somehow make it really want to figure out things in the most generalized way, then it might happen. I mean, nowadays we can do a very lengthy prompt saying, "Oh, you are a scientist. You will do whatever to make human beings thrive. You will figure it out. You dive deep. You will not stop until you find an answer." Maybe that's a proper prompt. I don't know, but I think the intention is, instead of having them as tool, they do have the potential to work with us, or even faster than us. Not necessarily better, but of course faster. And imagine we can have an army of scientists, uh, yeah, working 24 hours. I think the beauty is it doesn't require super hardcore science expertise to understand city or to be able to analyze city, right? Most of the time we use common sense and curiosity when we can peel off the layers and try to have a fair understanding of the complexity, and that is already good enough. It doesn't really have to give us a accurate answer, but even some interesting findings or interesting hypothesis that would be also helpful. So yeah, curiosity is, yeah. I don't know what's the right way to do it, but I think it's potentially doable. Yeah.
And I see what you mean when you say it's curiosity, but not really curiosity in a sense, because indeed, as you said, it's really important to remind it, especially when we are talking about AI
Mm.
agents, and you
Yeah.
did it multiple times. Those are not human beings. They are not even close to being kind of human beings. So as you said, it's something else, some hypothesis, prompt engineering that we are doing,
Mm.
that you are doing in this case, to create those kind of tasks that look like with our own labeling and
Yeah.
framing to curiosity.
Yeah.
We have several questions in the chat, and we will definitely ask them, address them just before time to let enter our special guest. It's almost becoming a kind of tradition now to have last minute Urban AI members joining the conversation. And today it's really a great pleasure of welcoming Federico Fernandez. Hi, Federico.
Hello, thank you for the invitation. Thanks a lot. And nice to meet you, Roy.
Hello. Hello. Nice to meet you.
So Federico is the CEO of Urbanly, and really one of the pioneer in urban simulation, based in Argentina, but working with worldwide stakeholders on integrating AI for urban simulation. You might know, if you've been following Urban AI for the last few months, like he was an instructor at the Urban AI Academy. He wrote a very much appreciated and shared article on using LLM for zoning acquisition. And so, yeah, it was kind of almost very obvious and evident to make this invitation of this topic. Federico, you heard Roy presentations. Do you have any questions, reaction you would like to share?
Yeah, I have a lot of questions, but I will try to reduce to give room to the rest of the people. So, yeah, right, very nice to meet you. Congratulations, not only because of your work that I think is unique and very innovative, but also the way you have to communicate that and the visualization that you show. They are wonderful. And it's also just one small remark on what you were saying on accelerating the profession. Totally share that idea. The same happened, I mean, with my models that in the past required doing some coding, and it was difficult for urban planners to do coding. Now they can ask Claude to, create code to modify the behavior of the model. So yes, I think we are witnessing an acceleration of many professions. On questions, perhaps the most, I had a couple of questions, but let's take only two. When you were talking about traffic prediction and creating a kind of specialization of a model, it's like a neural network that you are training. It's something, I mean, if you have, you can give a couple more details. And then something else, that second question, and I promise is the last one. When you are talking about the LLMs and mobility decisions, of course, connected with land use and their activities, if you can elaborate a bit more on how you are incorporating the human behavior and those decisions on the models.
Yeah. Start with the first question. You mentioned how do we do the traffic prediction, right? And yes, we try different approaches. We try traditional machine learning method, but also deep learning models, and we pick which one is performing the best. It's like a typical modeling process. But the unique thing, I think, is that, as you can see, that the prediction result is also like gridded spaces. So we did some pre-processing of the traffic. We use traffic speed as the independent variables. The dependent variables, and the rest we harness whatever we have in the database. So there's like hundreds, but we narrow down to like 50 something. And we try different models. We tried random forest, tree-based, or other regressions, or deep learning. We tried several times, and we picked the good enough one. For the sake of the demo, we didn't, put too much effort on the accuracy, but it's doable as long as we spend more time. So the idea is there will be more and more not downstream, but domain-specific pre-trained model that's available. Imagine some other labs around the world will share their really powerful model, really good at predicting traffic, and the agents just simply adopt that. Or there will be a platform where the agents are free to access to all the shareable domain models and perform. So yeah, I think that's a very wonderful kind of mechanism that we planners or scientists or whoever interested in the topic just took advantage of that. So that's explaining to your first question. And second, I think, because of the time, I didn't really get a chance to read down to the nitty gritty of all the process. But like you said, how does the LLM capture human behavior? One thing I would like to highlight is that because the LLM here we use is from OpenAI, GPT-4 or something like that. So it's a generalized model based on all the human activity around the world. Usually, most of them are from the Western, of course. So it had trouble at the first attempt to understand what the local Taipei people are actually behaving. For example, the college students. In Taiwan, the college students go to karaoke or they drink coffee rather than alcohol, something like that. This type of local context is absent or diluted in LM. So we have to do like local context prompt. Imagine we have to give it a sort of a background story of a city. The people in Taipei, they love karaoke more than bars. Yeah, something like that. So it would dictate the outcome. But as I mentioned earlier, using LLM as an engine to simulate human behavior, it has its advantage. It's more realistic in a way, but we have to be mindful about the local context. It might be diluted. So there's a certain way to compensate that by giving extra data points. So yeah, that's how we conquer that.
Thank you. Thanks a lot.
I might have a question for the both of you, actually, and this question is resonating maybe with a question from Bao Deng. I hope I will pronounce your name. Who said, "Does the simulation work if we don't have the digital twin of an interested city?" So that's a question from Bao Deng, and maybe my question also to elaborate on this, as you've both been working extensively with urban simulation, what are the technical layers needed to run the simulation, and how complicated is it actually to have it? Because you say, yeah, I will let you answer.
Okay, I'll do first on the first answer, also from Bao Don. I think, yes, if you look at the workflow, I mean, here are the essential data sets that we need to take into consideration. So without this, yes, the system doesn't really work. But I think there are ways to work around that. But if it's not missing too much, but if it's missing a lot, I would say the current workflow doesn't really apply. Or we can make fair assumptions, like some of the. I'm not sure about it, but there is potentially a way to do synthetic data for city that doesn't really have such data sets. Maybe we take other cities who have those data and train a model to make a fair prediction to this target city. So that's theoretically doable. And I like to use this example of Google Earth AI. They are literally doing that, and they're providing a foundation for people to do something like that. So I think that's potentially doable, but I'm not really sure. I haven't really done the work. Yeah, so that's answering the first question, maybe. Yeah, Federico, if you want to.
Yeah, those are super interesting thoughts. I would say that, yes, acquiring all the data that we need to run the models I've been working on for the last 15 years, it's still a very important challenge. And of course, I am optimistic that with AI, we can basically accelerate treating that synthetic data and those proxies. And that's part of the transition that I think needs to happen from simulating policy in a city being a big consulting project that will take months to doing something that can be accelerated by acquisition with AI and other techniques. Of course, we have been treating synthetic data in the past with machine learning and other means. My expectation is that that will be more accurate and probably faster now. And yes, I hope. I mean, I am putting a lot of energy in my startup and my group on of course finding ways to create simulations without having all the traditional data. It's a lot, and it's a lot of overhead for adopting the adoption of technology.
Yeah, and to the second question, what's the critical technical layer or technology layer that's sort of required in order to do this? I would say maybe not so much on the technical side, but the data availability is definitely one of those challenge. If you're working with a city that has already quite a sufficient open data from the public sector or from the private sector data, or something that you can pay for, that would be a good starting point. And without that, it might be trickier. But I would say there's a lot of organization or a lot of global coverage techniques that could potentially decrease that barrier to a certain degree. Like I mentioned, Google is doing that, Meta is doing that. Yeah. So and the urban foundation models, that's a hot and trendy academia research topic. So theoretically, you can apply a foundation model to, to predict those regions that doesn't really have enough data. So that's ongoing trend right now. So I would say that's probably the most important thing. Then it's the talents or the environment, the computation, or the good environment for the researcher to do, creative works and to bounce idea. I think that's a second. The second might be the environment. Yeah, I'll share that. And I'm not sure, Federico, you have any insights on that?
Yeah, but very short comments. Totally second what you said. Yeah, about data, there are many cities that perhaps have the data, but there are issues with formats or silos among the different municipalities. Then yes, we need standards. That's super important. I am pushing for standard for like planned projects in cities. If we had something like that at some point for all the researchers and startups, that would be wonderful, because that would help a lot. And my last point will be training of the public staff for an effective adoption and incorporation into the policy decision workflows, because many times from academia or the startups we do some very sophisticated models, but then we also need to find ways to simplify adoption with very good training.
Yeah.
We had several questions maybe that we can go through from the chat, both on YouTube and on LinkedIn. One on YouTube is from Alfred Newman, who is asking, I think it's actually for you, Roy, are you considering addressing or incorporating more third-party live data could be used in the inference phase, but wasn't included in the training?
That's an interesting question. I'm not too sure what was the purpose of that, but I think I can give some comments on the third-party live data in general. Up until this project that I shared, yes, we didn't really use much third-party, especially live data. We did streamline the vehicle detection data from the government. That's live data, and it changes every minute. But when you do training, it's kind of frozen in history, and we don't necessarily use that to predict the live traffic, because that's not our focus. But I can imagine there's a lot of use cases predicting like live activities. I'm not sure if I get the question right, but
we got actually a follow-up comment from Alfred Newman, who said, for instance, if we want to look at making the city more resilient, we may want to incorporate different climate forecast models, but fine-tuning an LLM may be prohibitive.
Yeah, that's an interesting question. We haven't thought about that yet, but that's definitely something that in the actual use case we should incorporate. Yes, and one thing I have been addressing to the team, and also in many occasions, is that all the data that we can train upon are using historical data. It doesn't necessarily tell us what the future is going to be like for sure, right? Because the future could always be black swan effects, new variable come in, it would disrupt the entire system. So we need to be mindful about applying predictive modeling method. There's always a sort of a limitation to that, and especially we need to communicate this clearly to our audience, should they be city governments or whoever's adopting the advice. So I think that's even more critical when you're talking to the actual users. And yes, incorporating like more data, especially for the live or the future casting, that's a big topic, and we haven't really have a good answer for that yet. Yes.
And that's indeed very interesting. Thanks, Roy, for reminding that it's not about predicting the future with those tools, actually, but it's really about, you said it very well, it's about some boxing, in a sense, some hypotheses and working on them through new tool. Maybe one last question from Noral Fisha Suleiman. I'm really sorry if I mispronounce your first name. How can AI agents fuse multi-source data to detect, predict, and visualize hazard scenario? Is it possible? And this is indeed a very critical question.
Yeah. In our workflow, I don't have a workflow diagram here, but it's not always the AI agent doing the data fusion. It's I mean, like the pipeline or the workflow that I share here is pretty much predetermined by us. We decided how the data being aggregated, what's the calculation methods, do we do average or do we do the median or of certain values, things like that. And of course, it's partly based on our own expertise or limitation of knowledge. For example, I am urban planner. I've been analyzing transportation or urban developments for quite some time, so I know which data or which attribute to look into in order to tackle what kind of problem. So in your question, if you have expertise in hazard scenarios like floods, heat waves, we should consult experts to see what data points are critical and how to look into them. Then we process the data, and the last step is hand it over a toolkit or data sets to AI agent. The AI agents, of course, they can do data processing or data fusion on the fly theoretically, but they don't necessarily have the deep knowledge of as human being. Maybe one day they would, equip them with knowledge as an expert that you can find in the top tier school. But if it's not there yet, then it relies expertise, domain knowledge to pre-process data. Then the AI agent is simply fetching the data or doing like some mathematical calculations or filtering for the user. So I think, yes, it's doable, but it requires domain expertise, heavily involved in the data collection, data interpretation, all the way to visualization, maybe. And then the AI agent is just replacing some of the work of human. It doesn't replace everything. Yeah.
Very clear. Thanks a lot, really, Roy. Thanks, Federico, for joining the conversation and the fascinating insight. Thanks, Roy, for your inspiring presentation and discussion. That was really amazing to go deeper into this topic of agentic AI. We will definitely want to be updated on the next step of CTAI and other of your projects, especially for 2026. That's already the end of this Urban AI conversation. Thanks for joining it and for your active participation. Just two things. First, we have an Urban AI member, actually a PhD student at Cornell Tech, who is doing a research on how AI is being used and perceived by planners. So it's definitely related to today's conversation. We will put his survey in his chat. I think it takes 2 or 3 minutes. And it would help a lot his research. So feel free, if you can, to fill out his survey. And last thing, next Urban AI conversation will be next week. It will be 1 hour earlier, so it will be at 3 p.m. instead of 4 p.m. Central European time. And we will welcome Shannon Valor. So that will be another fascinating and amazing episode to discuss ethics and Urban AI. Really have a look to Shannon Valor work. She worked a lot on ethical and virtues of technologies. That's super interesting. Thanks, Roy. Thanks, Federico.
Thank you so much.
Thank
you. Yeah, have a good day. Bye-bye.